Okay. Okay, so let's get started. So today we're gonna continue where we left off last time, which is mostly just an introduction to web servers and clients and how to talk to each other using the HTTP protocol. So today we'll do almost the same thing, but we'll try to go to the other end of the spectrum. So last time I was talking about, you spinning up your own web server, and setting up software like operating system, the security stuff related to that, then the actual Python environment, and then actually running your server software like prediction model, serving software. We'll go to the other end towards at least the end of this course, end of this lecture, which is about using AWS Lambda or Google Cloud Function, where you don't care about those things. You just care about your business function, which is you want to serve a machine learning model. Then how do I do that without worrying about Python setup or maintenance or operating system setup and so on? So you don't even need to know which operating system the actual infrastructure is running, actual software is running, okay, as long as it's Python. So we'll get there, but what I'll do is, again, last time there was Delta, right? So before the course, nobody knew what's going to happen in this course. And last time we saw something about the course. What I'll do today is revisit some of the topics from last time and then get on to the new topic for today, which is, as I said, basically serverless services that are provided by a few vendors in this, basically AWS and Google in this example, but there are other vendors who also do the same. So actually, let me then get to the slides. And what I'll do is I'll just quickly recap. So this slide deck is available on the syllabus page. It's just a short slide deck. What I'm going to do is, again, revisit batch ML section. In particular, I'll revisit the web servers thing that we saw last time quickly, and then we'll talk about serverless. Okay, and then we'll actually get into some hands-on stuff, which is try out creating a server on AWS, like an EC2 machine, basically. And although the emphasis will be on security this time, not so much about some of the things that we saw last time. Yeah. So this is actually the syllabus that we have. So MLOps is actually a bigger topic than this. And in fact, it has a lot of overlap with other things. I think in the previous slide, has overlap with machine learning, but not so much about model training and so on. But at least you should know, hey, I know how to curate data, how to, maybe data gets updated. What does the model artifact look like? Is it a bunch of numbers in a CSV file, or is it a pickled file, or is it something else? Some details like that. And then obviously it's related to data engineering, which is, I guess, a new name for kind of working with data warehouses, data lakes, setting them up for other users, basically setting up data access for other users and keeping it reliable and clean and all types of functionalities that are associated with it. And then DevOps is a more traditional area in software engineering. It's not core software engineering, but supporting that software engineering work processes. Basically, software engineers need a lot of resources, compute resources or other things, and there's the whole DevOps orgs, organizations in companies which take care of those things. Okay? So MLOps, in a similar sense, is not so much about, it's basically supporting data scientists, and not just supporting data scientists, but supporting the infrastructure that is needed to ensure that the company, if it has an ML product or some service that requires a ML based service, then how do you stand it up and actually maintain it and actually ensure that it works, okay, beyond a laptop, right? So although this last time we discussed the whole syllabus, but this time I just want to point out the first bullet point. We are actually going to be on this first bullet point for next lecture as well. So last time we saw web servers, and today I'll redo the web server part with AWS, so that that can be also a way for you to have a uniform, a simple server environment without messing up your laptops with all sorts of setting changes and things like that. The first bullet point is basically talking about if you have a model artifact already, somebody built it, like let's say a data scientist built it on their laptop or on their desktop. You have the model artifact. By artifact, I just mean some file, okay, maybe a pickle file, for example, or it's just a bunch of numbers. It's a linear regression model, right? Coefficients, right? You have a model at some time point, a snapshot, and then you just want to serve it as an expose it to users, where users submit feature vectors and they get back, classes or predicted values or whatever, right? So that's all you want to do here. So inference just means that, okay, submit a feature vector and just infer what the classes or what the predicted values and so on, okay? So the 3 bullet points, they just show the 3 parts of a sliding scale where the amount of effort needed where basically the scale is about how much of effort you need to put in to stand this up, to create this ML prediction service that somebody else can consume, maybe other teams in the department, in your organization, or maybe even consumers. But so what is the sliding scale? Web servers. So this is more like bare metal, serving up, creating your own infrastructure from like the ground up, literally buying servers, putting them in some data center or your own offices and maintaining them. So that requires obviously, taking care of the hardware, the operating systems and the reliability, and then worrying about something on top of it, which is maybe a Python-based function that you want to expose to users, right? So that's the first one end of the spectrum. You do a lot of things, including hardware potentially and software, other software which is not relevant to you for your business need or your current critical need. The last bullet point, this containers, is in somewhere in between, where you maybe not be worried about the hardware or maybe even the operating system, but you can do some kind of isolation so that you only care about a few things, but not everything. You don't care about maybe it's Mac OS or maybe it's Linux X or Linux Y, but you just care about your program and some supporting libraries that are needed for your program to run. Okay, so that's the second. I guess that's the third bullet point here, but that's a little bit away from completely maintaining everything. Okay, and the last, and the third thing, which is actually second bullet point here, which we will look at, is serverless services, where the name is a misnomer. There is a service, there is a server involved somewhere, but it's not exposed to you and you don't care about it. Okay, so you only care about your business logic. So in this situation, you care about business logic, and obviously you need to stand it up. But all you're asking from a third-party vendor, in this case, mostly it's going to be a vendor who will do other things. You just ask, what you ask from them is a Python environment, for example, and that's about it, right? As long as they give me a Python environment, I don't know whether it's running on a Mac or a Linux or a Windows or whatever, in 1 machine or 10 machines, I don't care. Just give me a Python environment where I can run a function and I'm good, right? So that's the setup we'll see today. So it's just in complete contrast with last time, and then we'll do the middle ground, which is containers, because it requires a little bit more exposure to other things next time. Okay. So what we'll do is just quickly recap the diagram and some tool names from last time, and then we'll actually try to spin up a machine on AWS just to do that, go through that flow, be a little bit more confident on it. And this requires, I guess, obviously an account on Amazon Web Services. If you're a first-time user, you do get a free tier where you can actually spin up a machine for 1 full year and you don't get charged. If you want to try out some things, you can do that. Okay, not just a machine, you can get other things also included if you're a first-time subscriber. Okay. Okay, so let's actually therefore talk about what we did last time. So last time we introduced the notion of, okay, if there's going to be a machine, if there's a machine learning artifact and I need to wrap it around with a server with a service which sits on a server is just another machine and listens to other people requesting, hey, give me a prediction for this feature vector, right? So that means that service, that our program, which wraps around this model, is going to be listening on some port. Okay, some port of this server. The server will have an IP address. IP address is just like a physical location address, but I guess for the internet. And so on, and not just the internet, but also in intranet, like your own organization's network. So it's sitting, so it's a program that's continuously running. It has the model loaded, and it's just waiting for somebody to send a request in an appropriate way. Okay. On listening to a port. Okay. Last time we saw a port, I don't know, 5,000 or 8,000 or something like that. So it's listening at some port. And so, and it's waiting for some request to arrive. And the request language is through these HTTP or hypertext transfer protocol language. So there are some verbs, action verbs, get, post, update, delete, a few words like that. Based on those, based on that protocol just means an agreement and a predefined interface of how things interact with each other. In this case, so it gets, let's say the running program on the server side gets a request. Then it's going to parse that request, extract the useful items there. For example, where is the feature vector? How is it defined, right? So that's why last time we saw, I think, .args or .params or something like that. So get that information, pass it through my model. Maybe the model is instantiated with a function, call f of x, and then get the class or prediction, and then return that as in an appropriate format to the other side. Okay. So the format, I think last time we saw JavaScript object notation is just a dictionary-like thing that can be serialized over the wire. Over the wire just means it's a dictionary that we see, and it's sent through the HTTP protocol back. And on the client side, they can actually just see essentially the dictionary. Okay, so they don't have to do any extra function call to kind of parse it or anything. On their end, there are helper functions or things that are defined already. Okay, but as the name suggests, it's a text protocol, so it's all. If it's just a bunch of strings and numbers, then it's the easiest way to do it. If it's not, then you need to do more. Okay, it's not going to work like this. As long as it can be converted into, I mean, if you want it to be interpretable, you have to do something more. But if not, if it's bunch of if it's not a string or a number, if it's something else, let's say an image, right? Image is also a bunch of numbers. Let's say it's some other object like a executable. All those things, they can be represented as bytes at the very minimum, bytes or bits, right? Those things can also be transferred. It's not going to be interpretable. You can't read it, but it's still a text protocol. Okay. So anyway, that's the story on the left side. On the right side, so today we'll quickly see EC2 aspect of it, and especially the security aspect of it, because I did not talk about it last time, because we did everything locally. I believe most of us. And the second thing is the client, right? So client, we saw last time, there are multiple ways to interact with a service. In fact, somebody was able to successfully run the weather service example. So how do you make a request? You can make a request through a command line, through a well-known utility called curl or curl. But that's not the only way. There are many ways to do it. We saw last time the request library that's available in the Python standard library. A request module, you can make a request through that module. Or last thing is you can just, if it is something which is easy to do from a browser, especially GET requests, it's easy to do. So you can just use a browser to make a request. Okay. So we saw all three ways last time. Okay. So that's the quick recap. Any questions here that was not clear or something hard? I know some of it is easy for some of you, but for some of you, maybe it's new. So we'll do a quick recap of this after I cover, what is serverless stuff. Okay, so last time we did not see all these tools. I think VirtualBox, I think has some issue with M2 Max. I don't know. Last time somebody was mentioning it, but VirtualBox is a way to kind of virtualize an operating system on your laptop so that it can be completely isolated from your rest of the laptop files and settings and programs and everything. And you can run Windows on Linux, Linux on Windows, Mac on Linux, whatever combination you want. And it's a basically isolated, completely isolated virtual machine that you'll get. Okay, and when we're going to rent a machine on AWS, and that's also going to be a virtual machine. So you can create a virtual machine on your own VirtualBox, which is obviously running locally, or you can rent a virtual machine from Amazon or elsewhere. And there are many vendors here. Okay, SSH is something that we did not see, if I recall, last time. So SSH is a protocol to get into a server. So let's say you you rented a virtual machine from AWS, you need to be able to log in and do stuff, right? So how do I log in? So there has to be some other service running on the other side to actually let you log in. Okay, so that's how all these things work. So we'll actually see SSH when we try to secure our AWS machine. Okay, these are just a couple of things that we'll see when we do the demo. And then tools. Last time we saw, how to spin up Jupyter Lab. We're going to do it again. In fact, we'll spin up Jupyter Lab on our side so that we can be a client and we can actually contact the AWS machine and actually get a prediction back. Okay. And then we didn't see many of the other things. I don't think we saw pandas or PyTorch or anything, but these are just auxiliary things. If it depends on, if you're modeling or whatever depends on them and you use them. Request is what we saw to actually make a request. Flask is another important thing that we saw, which is actually the program that wraps around your function and actually lets us do one key thing, which is map a URL to your function. Okay, so if you hit the AWS machine and say, hey, IP address /predict, okay, /predict is going to be mapped to a function, and the Flask is the one which is enabling that. Flask by itself is not a web server. It's not a production grade web server. When people say production grade, it's not used by professionals, but it's, for us, it's a good, quick way to try things out. Okay. The other words, we're not going to look at it, but Poetry is a way to manage. Like last time, we were using virtual environments through by just a VN library, VN module. But you can create virtual environments using other modules. Poetry is another kind of tool in the same category, which lets you manage. Very similar to Anaconda and Conda command line utility. Poetry can also help you do that. Okay. Command line arguments, command line commands, CLI commands. There are many commands. I think today we'll try to maybe do a couple of more commands than last time. Okay. But these are all ls and cd are like list files and change directories, and sudo is something that makes sense for maybe Mac and like Linux, where you want to kind of have elevated permissions while doing something. It's like the administrator choice that you might need in Windows, right? And we'll see some of these commands as we do a demo today. Okay. So before I switch over to the demo mode, I want to also very briefly cover serverless. Okay, let me skip that part first. We'll come back to slide 7 later. So let's actually briefly look at serverless. There are actually more notes in the course repositories, chapter 2, I think, or whichever chapter it is. But instead of looking at going through the course notes, I will just look at the slide and then get into the demo. Okay. So this setup is almost the same as the previous setup, except there's some extra names here, right? So the left side is the same client, and you can use request, curl, web browser, whatever, depends on what your request type is. So you can make get and post requests. Get request is where you're just asking for, so what's the difference between get and post? Get is generally mostly used when you want to retrieve a pre-computed quantity. And post is when you want to kind of give some information to the server so that it can store in a database. But last time we were just doing a get request with a feature vector being part of the feature vector, as in just a feature value being part of the get request. So you can abuse it, but they have some, I guess, canonical purposes. So in serverless technology, what happens, and it's basically common for both, at least Google and Amazon, and it probably is very similar on Azure as well and other vendors, is that you basically, it's all modular, and you don't care about anything beyond the Python environment that you want. Okay, so what you ask, that's one of these cloud vendors, is, hey, give me a way to give me an IP address, and that thing that, give me an IP address that can map to a function. Okay, that's the same thing like the Flask was doing, mapping to a function. So that's this trigger gateway part. Somehow, kind of connects your IP address / some location to a function. And then the function itself, which obviously the function is for us will be some Python function, like, hey, do this, predict that, or whatever. And the function itself needs just the Python environment. And if you need additional packages, you can install it, like pip install XYZ, or mention that in what is called a requirements.txt file. And then everything else, which is the actual security, obviously we'll have to do something more, but scaling scaling means like if you want to have, let's say your prediction function takes 10 seconds to make a prediction. Maybe it's doing a lot of computation, maybe it's processing an image, or maybe it's doing KNN, whereas the number of neighbors or the database size is huge, and it's not pre-index, whatever. If it takes more time, you can always make copies of it, right? So so that scaling, that replicas, for example, can be achieved by just like flipping a number in some setting. Okay. Resiliency is exactly what it says. Most of these vendors provide service, guarantees that your system are, basically our system will not be down, their system will not be down, as will only be down like a few hours a year or a few hours a month. Like a few hours a month is a bad thing, but a few hours a year is like a very high quality target to meet. Okay, they guarantee that, so that especially critical applications, you kind of need that type of thing. Okay, so that's the only difference. But the way we'll set this up is obviously not by coding. Last time it was just getting some. We stood up everything, we installed Python and everything. But here we'll not do that. Some parts will be skipped. But then the new things will be trying to work with these cloud vendors. At least they keep changing the features and interface. But at least we'll just do it via the GUI. Okay, this time. But there are actually multiple ways to interact with cloud vendors, just like multiple ways to achieve any single one of these. Either on the server side or the client side. There are multiple ways. We'll just use the UI this time. Okay. Yeah. So we'll not. I mean, so some of the tools here are if you wanted to do multiple ways of achieving the same thing. But here at the minimum, you need one of these accounts, either as an Amazon account, a Google account, or both. That's the examples that I think I'll try to show today. But you can also try on Azure. The actual services that we'll actually work with is in Google, it's called Cloud Functions, and Amazon, it's called Lambda. But this is the technology which lets you ignore everything else and just ask for, hey, give me a Python environment. I'm just going to define a function and done. Okay. You can interact with these vendors using command lines. So AWS CLI, I think it's called. So these lowercase names just mean that their program names are literally just called those. Okay, so you can actually download these programs, whether you're on Windows or Mac or Linux, and they'll just be installed if you want to interact with the cloud vendor through the command line. If and many people do that actually. So okay, so with that, let me jump to the demo part. Okay, so as I said, what I want to do is actually really emphasize two things which were kind of complementing what we saw last time. Okay, so we just want to focus on security and use of SSH. Okay, that's they're simple things, but we just want to at least comment about it when we rent a machine through, let's say, this vendor. Okay, so I already have an AWS account, but if you guys sign up, you need probably a credit card, but you, as I said, you have a free tier, so it'll probably not cost. So EC2 is the name of their service. They have different names, but acronym EC2 stands for Elastic Compute, I guess, and they have a ways to. This is how you can rent a machine from them. Okay, and so right now, so they have regions as well. So it just depends on where the data centers are. You can see the tons of regions here. But some default region, you just need to remember which region it is, but just remember which region. And so you can see that we can go to instances and just there are basically the call to action here is basically launch an instance, right? So we'll try to launch an instance, and okay, let's call it some name. And there are many options for what operating system you want to run. So we'll just go with something standard. Let's just go with Ubuntu, although it does, Amazon has its own version of Linux also. So it says some name here. So here we're not really choosing anything. Just since the last time we used Ubuntu, I'm just using
So, the OS that we choose for our virtual machine shouldn't be consistent with what we are using on the client.
No. So client and server only talk through HTTP language. Client could be in in a Windows machine or whatever, a server could be in some other machine, but also the programs in both sides need not even be Python, right? So the server could be serving a Python-based thing. Flask is a Python-based, let's say, server or whatever, web server app. But the client could be written in Go or JavaScript if you want, right?
How is HTTP converting or interacting with different
there are libraries which let you talk through this common protocol. HTTP is a very versatile protocol. I mean, all the browsers, in fact, when I hit that link over there, this is actually a HTTP request, right? So I don't know, have you ever tried opening this debugger here? So here you can actually see, actually maybe not here, but here, for example, you can see what requests were made. And I don't know if you can see the headers. But you can actually see what in plain text, you can see what the request was made. It's literally just says HTTP protocol, what's the client? Hey, this is the IP address, give me this information. And that's how you get that information. Browser is nicely arranging it so that you actually, have nice boxes and click down menus and all that. But it's all text.
Why is this important? Why do we need to choose an OS? If it's agnostic,
it's not. I mean, we need to kind of go into the server and set, start our Python thing, right? That's all. It's not important. I mean, you're just being consistent with what I did last time. Yes. Okay, so it's a good question, and you can pick anything here. I'm not even going to change things. So I don't know if I have a key pair. Let's create a new key pair. So key pair this is where the security part comes in. Okay, so we're gonna log into the server, set up Python, and set up our program, class-based program. But to log in, we need a secure way to log in. So S part of SSH stands for secure, right? Secure shell, I guess. So we'll try to, but to do that login, what Amazon is saying is that, hey, generate a cryptographic key pair. Okay, this key pair is an interesting concept. What the machine will do is it will retain what is called the public part of your key, and you will have your private part of the key. So public part of the key, just think of it as places where you want to put a lock. Okay, and the private part of the key is actually a key that you can put in your pocket and never give it to anybody else. Okay, so what Amazon is saying right now is, hey, we're going to create a key pair, and I'll keep the lock with the virtual machine. You take the key. They'll let me download some text file. Basically, I keep the key, and you can, if you want to log into this machine, use that key to get into this machine. Okay, and when you get into this machine, you basically will see the exact command line stuff that we've been seeing throughout. Okay, that's the concept. But the interesting thing about these key pairs is, maybe not Amazon specific, but like this SSH based key pairs, is that lock can be put in multiple machines. It's fine. I mean, you can copy locks, but in physical space also you can copy locks probably, but that's the only I guess. So it's not an Amazon specific thing. Amazon is recommending, and in fact will not let you, I guess, spin up a machine without you doing this. So let's just pick something. So there's encryption choices here, which we don't want to get into. RSA is a little bit older technology, and this ED5 255.19 is a little bit newer encryption, I guess, mode. So let's okay. So and it's giving us a couple of suggestions. So people in Windows who use Windows might want to choose the second one. If you're going to use the PUTTY utility to connect to remote machines, okay. But on Windows, if you've already used already enabled WSL2, then you don't need this extra complication. But if you don't want to have WSL2 installed or whatever setup, then you want to get the .ppk file. Okay. So create key pair. Okay, it just downloaded something, right? For now, let's ignore that. Okay, now here's the next setup security wise. So I'm just spending some time on security because you don't want to spin up a machine and then somebody else, tries to get into it. which people do. Okay, they're literally searching for, scanning through Amazon's IP space and like trying to see which ports are open. Are they running vulnerable software? So it's not. So internet is unfortunately not benign. It's not a good neighbor type of situation here. So it's saying, okay, so a security group is just a name for like, okay, collection of rules of what can kind of talk to the machine that we're rendering. Okay, so by default it has enabled this SSH thing. Okay, so secure shell. And you can, so right now it says connect from anywhere. Okay, so you can actually even restrict it. Instead of saying connect from anywhere, let's say you're working from home or from your office, generally your ISP or internet service provider would kind of give you the same IP. So you can literally just say only allow connections from my IP address. Okay, if your IP address is fixed. Okay, and what is my IP address? You can literally go to Google and say what is my IP. The many services will tell you what your IP is. Okay, public IP. Okay, so you can specify instead of 0.0.0.0, which corresponds to any IP address, anybody on anybody who, as long as they have this key PM file or whatever, can log in. Instead of anybody, if you restrict the IP to be specific numbers, then only those people can log in. Okay, that's even further like very secure. Okay. Yeah. So it has a couple of other options. Generally, people rent machines so that they are, let's say, for example, to talk, to actually make it as a server. Okay? It serves, it serves something, right? Generally, web pages, for example. And so if it serves web pages, HTTPS S stands for secure, and the plain HTTP, if you want to let people actually talk to it and receive web pages, then you want to enable these two. We can actually come back to this later. Yeah, we can come back to this later. And then that's about it. I'm not really doing any further changes. I just downloaded a key and everything else is default. We just chose Ubuntu machine, right? So storage, by default, I think they gave a small storage like 8 GB. If that's enough, if for your CSV file or anything else or your program, that's fine. But I'm just gonna increase it. I don't want to come back and have a data issue. Whatever, space issue. So okay, so I'm launching one instance. It's taking Ubuntu. It's some server type. So micro is probably less capable, and then bigger ones have more capability. You can also rent a GPU. So I don't know if some of you are need a GPU for a short period of time. You can rent, and don't forget to obviously terminate the instance. But you can rent an instance for $2, $10 for whatever workload you have. If you want to train for an hour, it's like $2-3, which is expensive. Okay, but it's not expensive. You just want to try it once and train something and get back the results. Okay, so let's just launch this instance. Okay, so it's successfully launched something. So let's actually click on it, or we can actually just go back to the instances pane and it'll just show it. So this is our machine that we just rented. Okay, it's pretty quick. Amazon is, all these vendors are able to quickly spin up machines on demand, right? This is also called an on-demand instance compared to a spot instance where you can get something for cheaper, but if somebody else needs that machine, your machine will get terminated. Okay. So details, right? So the machine has some private IP address, and the machine also has a public IP address. This is what we care about. It costs money. So Amazon is starting to charge money for the public IP address as well these days. But this is the IP address through which we will connect to the machine. Okay. So that's the information that we need from this page. And we want to just go to security and just check what we have, right? So it says the security group is launch wizard 4 or something. Let's click on it. It'll show what the rules are. So you can see there's a couple of panes, a couple of tabs here, inbound rules and outbound rules. Let's click on inbound rules, and you'll see that currently the security is only letting one type of traffic hit this machine. Okay, it's saying on IPv4 or the IP address that we see, like the 4 numbers with dots between, that's IP version 4. only SSH type of traffic with some underlying protocol like HTTP protocol. TCP is also a protocol which is at the lower level of networking. You can only go to port 22 from anywhere. That port is open to this machine. This machine will not talk to anybody else currently. Okay. Remember, now we need to deploy our machine learning service, for which we need to open a port at some point. Okay. So we'll need to do that. So we can actually edit the rule right now by saying add a rule. Custom TCP is fine. I don't remember last time for even, is it 5,000? 5,000? Okay, let's just open 5,000 for now. And this is a bad idea to let everybody access it. Unless you intend it to be a web service. Like if you want literally serving web pages, then yeah, anybody from all over the world can visit your web page, your blog or something, then it's fine. But for temporarily, I'll just open it for anybody to connect. And that's it. So we'll just add this rule so that once we start our service, we don't have to come back here. Okay, so now let's go back to that instance and just get the IP address and try to connect. So, okay, I copied that. So before that, I want to quickly start the. So remember last time some of you did this, like you created a virtual environment. So every time you want to use it, so one of the advantages of doing that is if you have different projects and you don't want to mix up the packages and all that. Okay, so if you have a default Python instance and that's the only thing you're doing, then it's okay. But here I'm not by default. This has some Python in the system, but just like Macs already have Python in the system, but I want to use something separate to that. So I'm just enabling that virtual environment, and I'm just going to start Jupyter. That was the purpose of that terminal, so we don't need that anymore. So okay, let me. Okay, so it's the same thing. You just open in a different tab. So this is where we left off last time. Okay, so now what we want to do is so I'll just copy it. Okay, yeah, I'll copy it here. Right, that was the file that I got. It downloaded into the downloads folder. I just moved it here. Okay, this is the PEM file, and I'm just gonna ls-la. So is a way to see like whether this file is readable by everybody or not. Okay, so you might see the same thing in Mac, but not in Windows. It's just saying, hey, what is the directory? So if you see like these blue things are directories, so that's why there's the first letter is D here. If it's just a file, then the first letter is going to be a dash. Okay, and the first three characters, and the next three characters represent whether you as the owner have reading, writing, and executing capability on this file or folder. Okay, so why I'm mentioning this is because right now for this key that we have a read-write permission, and the next bunch of RWs that you see, RWX that you see, is for people in your group. Okay, so generally, I don't know if you've heard about this, but you are a user, you are part of a group. Okay, and then there's everybody else. Okay, there are three types of people in a Linux or Mac machine. I don't know if in Windows it's like that, but basically the second set of RWX is just saying, hey, everybody else in your group, can they read, write, and execute this file? Okay, and so what I want to say is that this file currently has other people in my group can read and write, and everybody else can also read this file. Okay, this is a little bit lax security. Ideally, you want to convert this to a file which only I can read and nobody else can read or write. Okay, yeah.
Is the group identified by the IP address?
No, this is just local to my machine. So every machine will have, non-Windows, but like Mac and Linux, they have this permissions thing where there's the user, there's a group of the user, and there's everybody else. Okay, it's just a historical thing from couple of decades ago, sorry, few decades ago. Yeah, just some charts. I just want to show you this, but that's so SSH minus I MLOps fall something. Then Ubuntu is the default user, that Ubuntu based operating system. If you use Amazon Linux, it will be called EC2. Okay. But these are things that you can see from the documentation. I'm just shift at the rate. Oh, that's not the, I thought I copied the address. Yeah, so that's the IP address. That's the public IP address. Okay, so I'm just saying, hey, SSH with this key into this machine. Okay, and with the default username is just Ubuntu. And first time it's saying, okay, I don't know. So first of all, when I'm trying to use a key in a lock, first of all, it's trying to say, hey, do you know that that lock is actually genuine and not something, which is not trusted? Okay, so we can say, okay, it's a trusted machine. I just entered it. I know it. And so let's say, you can just press enter. Oh, it says host key verification failed. So let's change the permission to 600 of this MLOps for all key. Okay. chmod is just a way to change who all can read that file. And okay. And now we've logged in. So what did I do there? I was a little bit quick, but I just changed I don't know if it was because of I did not press yes, or I did not change the permission, but I just showed you what's the right way to do it, is just make the key not readable or writable by other people. Otherwise, some operating systems will complain. I didn't want to show the complaint. But once I did that, I just pressed yes also for that. Can you trust this host? And then I got logged in. Correct. So this is the rented machine. So it just took a few minutes to ask somebody to rent me a machine, and it doesn't cost too much, especially a low power machine. Now you have a machine. Now what do we need to do? Is exactly what we did in the class last time. Set up a virtual environment, download the code, and and then Python file name.py or whatever is the command that we did. Okay. And since we opened port 5000, we can actually just access it. Okay, anybody can access it. I mean, you guys can access this machine with the same IP address. Yeah. Yes, so on this machine, there is no virtual environment, right? So this machine is completely empty. It doesn't even have the several code. Yeah, so it's not complicated, right? So this is where the command sudo apt install Python 3 when will come, because that's how we'll create. So sudo is the command, as I said, to get to administrator level. Apt is a package manager for Ubuntu. It's like software. It knows what's like. If you ask it to install this module, it'll figure out where to get that module and install it, and where to get the software and install it. So okay, that's not the right name. Okay, let's try. So which is another command to know like where is like what. Okay, there is no. Okay, there are a couple of Python installations, or at least it's the which is just kind of figure out, is Python available in this machine. We just entered this machine. We don't know, which is a way to know, okay, is there a Python in at least some path that we can, okay, there's some Python there. So we can try actually Python 3 minus m, the command we saw last time, and see if it works. If it doesn't work, it'll tell you what to do. Okay, so it did not work. It said, hey, it's not there. And so do apt install Python 3.10-when. I just did not do the 3.10 part, so it said it's not available. So I need the virtual environment to actually set up a virtual environment, right? So I can just go back and say Python 3.10. I'm just installing some extra software, okay? That extra software is needed for me to create a virtual environment. You may say, okay, why do I need a virtual environment in a... Oh, is that not the right command? I don't know if search is the right word. Okay, I think I don't know why there is an error. Okay, it is Python 3.10. I don't know what VN with that module is available for Python 3.10. I don't know. Last time we did it with Python 3.8. Okay, for now I'm going to ignore that and will not create a virtual environment. Okay, it's just not a good practice to do that, but I think we'll just move on. Yeah.
So where are you writing all of this?
On the machine. On the machine.
But is this command prompt or is this on Jupyter?
This is Jupyter's terminal that I'm using,
Okay.
but I've already logged into that other machine.
But then you have to use this terminal to log into that machine, right?
You can use PUTTY if you're on Windows to log into that machine as well. So you have to somehow log into that machine through SSH protocol only. Because remember, the SSH is the only way to get in that machine. We also opened port 5000, but there's nothing listening there. Okay. So if your question is, how do I get a terminal like this on your local machine? A lot of people have had challenges last time. But if you have Mac, you can get a terminal like this easily. But if you have a Windows, then WSL2, you'll by default get something like this. On Windows, you'll have a PowerShell type of a thing by default, okay, which is going to be different from this. Yeah.
Because you use the Ubuntu operating system, that's why you require
Remote.
change the
No, the change mode is just to, so even on Windows, if you right click and you'll get a who can read, write, and there's some tick boxes, right?
Your third group was
Everybody else.
Yeah, so it was at the read one. That's why you have to choose for the third group.
If it's insecure, we actually, since you have a question, so let's yeah, so in this case, see, I've made everybody read, write, execute, right? So you can see the one with the green. So 777 just corresponds to like setting all the bits to 1 for some reason. So let's not get into the detail of why the 777, but basically now I've made that file, MLOps fall PEM file, read, write by everybody, right? I did the opposite last time. So if I try to log in, it should throw an error, right? So this is the error. This is what I didn't want to kind of, I guess I skipped showing it. So it's just saying, hey, it's too open. That's why I'm not even going to try to connect. Okay, this might be compromised, this key, like somebody else must have copied it and they might have logged into your machine, right? So now I just, what I did last time was just try to make it 600, which just corresponds to if I do an ls, now you can see only I can read write and nobody else can read write. It's just some little bit more secure, I would say.
What is the number 65?
So 600 is just so you need to look at its binary representation. So 6 represents 0, 1, 0, I think, right? No, 1, 0, 0. 1, 1, 0. Yeah, 1, 1, 0. So 1, 1, 0, that's why R and W are set and X is not set. So 1, 1, 0 corresponds to R's being set, W being set, and X not being set. Okay. And 0 is obviously 0, 0, 0. So R is not set, W is not set, X is not set for everybody else. 777 is 1, 1, 1, and that's why everything is set. Yeah. Okay. I mean, if you didn't follow that, don't worry. It's just so what we wanted to do was I just logged out again. Let me just log back in. But now we are in the machine, right? So how you get there, if you're on Windows, if you want a simple, historically people have been doing it, and that's why Amazon even had an option, right? PPK file versus PEM file. Download the PPK file and use what is called PUTTY. Okay, it's a command line. It's a simple utility. You just need to provide the IP address, and here's the PPK file. You get a terminal like this. It will not be on Jupyter, but it's the same thing. Yeah. Which exercise? No, you don't, right? You can do this, right? So right now, for example, I rented a machine on Amazon and it's Ubuntu, right? So you need to figure out how you're going to try out the exercises in this course. Option 1, install VirtualBox and then install virtual machine, Ubuntu virtual machine. Therefore, you have Ubuntu. Option 2, if you're on Windows, especially enable Windows Subsystem for Linux 2, WSL2. That'll give you an Ubuntu, essentially Ubuntu container, but at the end of the day, it's just Ubuntu, so you can just have the same terminal and stuff. Okay. Option 3, buy a new laptop. Windows desktop, yeah, virtual box and then virtual machine would be, yeah. Yes, through multiple ways, but the way I'm suggesting is just install VirtualBox and then use virtual Ubuntu virtual machine. That way, you're not messing up anything with respect to your laptop. Just for this course, you have a virtual machine. You do all sorts of things there, and just delete it if you think you made a mistake or something.
Sure. Now we are installing Python on that rented machine from AWS.
Yes, which is where I failed with creating a virtual environment. But yeah,
Is it possible to use like another service, like a serverless service here, and use Google Colab for Python? On
Google Colab. Yeah, you can just install Jupyter here, right? So I don't know.
So Jupyter may not be efficient when we're doing big data tasks, for example. Right?
Colab versus Jupyter, what's the difference? Except for GPU access.
Yeah, exactly.
I mean, this machine doesn't have a GPU, but you can rent a GPU machine if you want. Actually, so on AWS, there's also a competing service called SageMaker, which we're not going to get into in this course. But SageMaker is exactly like Google Colab, where if you create a SageMaker notebook without GPU access, it's kind of cheap to run. And then if you want actually GPU access, SageMaker gives you like, okay, trigger a GPU, train it, and get back the result if you want it that way. Obviously, you can always rent a machine with a GPU, and then you always have a GPU. But it's not like Google Colab where if you don't use a GPU,
but we cannot go to Google Colab using a rented machine. That's the concept.
Using a rented machine. So I don't understand.
If I have to run like a code on which is running in Google Colab.
Yeah.
So I can place that.
So Google Colab is just a IPython notebook, right?
Right, but it's present on a different server.
On Colab server, yes.
So how do we access? Can we access that server using a rented machine?
You can access anything from a rented machine, right? It's just a machine. I mean, as long as you can access Google Colab from your desktop, you should be able to access Google Colab from rented machine as well. Yeah. I mean, I'm not getting into like the GUI part. Like you can install tools which let you remote desktop into this machine. Okay. But that's not the scope for this course. My objective for this is to just show you some security aspects and SSH aspects. Yeah, but you could literally, so whatever machine we rented, we can install additional software and then just do remote desktop, just like we were doing with Windows or anything else. Yeah. And then you have a UI, and from there, you can open a browser and go to Colab if you want. Right. I don't know why you would want to do that, but
given Jupyter Lab has its own disadvantages when it comes to running bigger data sets. I faced a lot of problems like we land big data from.
Okay, there may be, but we can discuss that separately because it's not in the context. Yeah, any other question before we? So I'm just gonna let's see. Oh, pip3 is also not installed. Wow. What happened to this machine? Sorry, I'm just updating the package manager to know that, okay, all these packages should exist. I don't know, it's failing right now. Okay, now it found pip at least. So it should probably also find when vn package. Wow, so many things to install, but so, it's okay. In the meantime, as I said, now we're only securely accessing this machine. If you want to run Jupyter there, but you should not expose it to the world, then you should look at notes, course notes, where it says how to use SSH tunnel to access Jupyter. So you can still access this Jupyter on the server on your local browser. So on your local browser, when you type, localhost 8888, it goes through the SSH protocol and goes to that machine and runs the Python stuff over there. Okay, so that's a better way than directly exposing Jupyter through the public IP. Okay, then anybody else can also log into the same, open the same Jupyter environment and do stuff. Okay. So, sorry, I just updated something. Let me just go back and just recreate where we were. So this is just saying, okay, something's outdated. Do you want to restart? Tab it, get to the OK, and press enter. Okay. I don't know why it's showing that. So now we have that. So let's actually exactly repeat. So this is on the server side. What do we need on the server side? Flask, right? That's the only thing I think, if I recall, we need. We'll also do git clone of that repository. Exactly what we did. I don't want to take too much time here. So here, it doesn't matter which one you choose, but so again, it's asking for some, do you know this machine and so on. It's exactly because that protocol, the SSH protocol and the HTTP protocol, there's some little bit more stronger security. I mean, both have, okay, what did it say? Okay, so let me just go back there and go back to HTTPS. I guess this makes only sense for if you're logged in, like if you are the owner of that repository, perhaps. So let me actually delete this. Did I miss? Okay, we'll go into the directory, Flask example regression. Okay, so now I'm gonna just do, just double check that it has things that it needs. Yeah, I think it has everything it needs. So Python Flask service.py. So it's only running at local host. So I want to change that. So if you want to expose it to the world, insert here, you have to say that it's a 0.0.0.0. Okay. So let's just do that. Okay, so it's saying the only difference from previous statement and the statement is saying running on HTTP only local host, so you couldn't access it from elsewhere. So it's saying running on all addresses, so anybody can access it. Running on local host as well. Running on this private IP, which we don't care. So anyway, the point is it's now running on port 5000. So we can just go to a browser and as long as we know the IP address, we can try to access port 5000 and see if it works. Okay. Right. It says input not passed. So actually the function did get triggered and said you did not pass it. Okay. So, and then if you obviously we did it last time, x is equal to 10 or something, and you'll get some response. Okay. So this is just a one-dimensional regression, and we just ran it there. But I want to complete the security story by one more thing, which is SSH tunneling. I will not show it now, but if we look at the notes, if you want to. So here we're just demonstrating it for running an ML prediction service. But if you wanted a Jupyter service always available to you, not running on your machine because maybe your machine is, you don't want to install Anaconda or whatever Python, then you can always rent a machine, run Jupyter there, but use the SSH PM file, the SSH protocol to connect to that Jupyter, and it'll look as if it's running. It'll just open the browser just like you would run it on a local. If you span up Jupyter locally, it will look exactly the same. Okay, so you could do that, but that's there in the notes. I will. One last thing I wanna say about security, because this is super important when you're trying out services, is so Ubuntu, for example, comes with a firewall. Okay, so what is the firewall? I think most of you use Windows and Linux and Mac. right? It stops services from connecting to outside or outside things coming inside. Okay, especially Mac will prevent you if you want to start a FTP server or a SSH server or something. So sorry. So UFW is the name of the firewall here. I mean, this is just a utility which behind the scenes does some other things, but UFW is the name of the firewall. Okay. So we can see it's inactive. So we can actually UFW enable. It says it'll disrupt some connections. So let's actually I don't know if it's a good idea to start it now. Let's actually so first let me enable that. Okay, I can at least SSH in. If I turn on the firewall and my current SSH connection can get disrupted, sorry. Okay, so at least the 22 port, it will not be firewalled by this. Okay, so now that I have it, then I can just enable it. Okay, let's firewall is enabled. So now if I do status verbose, it says this is what's happening. Okay, default is denying all incoming connections. Like if you see the third line there, outgoing connections, you don't have, you can deny also, but let's keep it open. And it's saying deny incoming connections except this, right? So port 22 TCP protocol from anywhere allow in. Okay, this is like a second level. So Amazon is already doing through its security groups, and then the launch wizard for whatever I had, it already blocking things. But if you wanted additional blocking, like so that you have to keep things secure. Okay, this is like public space where you're renting a machine. So this is another way to kind of safeguard your machine. Okay, but this completely ignores all the other things like authentication and all that stuff that we will not worry about. If you want a simple authentication solution, actually instead of Flask, there's another Python framework called Django. It has a nice authentication. Things are built in, like by installation you'll have it. You just need to enable it. You can try it, okay, separately if you want to try. If you want a Flask type of thing, but with authentication, so that people can actually go to your website and say first log in, then I'll give you the prediction, something like that. Okay. Anyway, so I want to stop the story here. Any questions with this part? Okay, so what we did is exactly repeat last time. Only thing that we did is we rented a machine from Amazon, and we started our prediction service, logic regression, whatever, linear regression, and we made our client was just a browser. Okay, instead of browser, we can do the request from a Jupyter or something, or a Python program that's running locally on our client. Our client currently is going to be our laptop. Okay. Yeah. Any questions here? Okay. If not, let's actually go to the serverless part. Since we are on Amazon, we can try out serverless. So what we'll do is directly go to Lambda and try out. So what we're doing is nothing sophisticated. It's essentially simpler than a quick start, actually. So we'll just do the quick start of them just to get a feel for what a Lambda function looks like. Okay, or at least the flow of setting up the Lambda function. The only key idea here is that you don't have to worry about the hardware. You don't have to worry about that T2 micro and all that complication, or even the ports and all that stuff. You can just request for a Python environment and define your file, define your function of what it needs to do. Obviously, the function might need access to a database or something else to kind of, get the model or something, or some other location from which it needs to get a model. But for simplicity, we'll not do that part. We'll just say, okay, here's a model with some coefficients and just respond, right? So for that, you can just go to Lambda. So it's I guess run code without thinking about servers. I guess that's their tagline. Okay, so I don't know. So it came here saying, okay, this is how you do it. This is how you do it. You just literally just define a function and that's it. Obviously while going through the flow, you'll choose a Python environment and stuff. Okay, so let's actually try to. So as it says in this page, you just, above the simple Lambda function, see the function out before going to the next step. So we're not gonna, so I think it's just showing you how to get things started on this machine. So actually let's start from like a clean surface. So if you actually go to the left side, this is the Lambda's menu, right? So if you go to the dashboard, right now, there's nothing going on. So let's look at functions. There's no function. So this is like the default. This is exactly like the pane that we saw. If you had like 10 functions doing 10 different predictions or 10 different activities, then here is where you see it. So let's create a function, right? So it's saying author from scratch, use blueprint, use container image. There are other more complex things. Let's just start from scratch. I don't know. Let's call it predict. And here's the runtime, right? This is the only thing you choose. So it's giving you all these options of different languages. On Python, you actually have all these Python versions. Let's choose Python 3.10. And it's also saying in case your Python code requires some architecture specific details, like you can just choose a few things. But otherwise, it's not. There's nothing else you need to choose. Roles. We will not get into the details of roles. We'll kind of not enable any of this. I think we might need to look at URL, but let's see if we need to come back to that. So let's create a function. You can always edit a function once you create it, okay? Just as a Python function. So that's what we're trying to get to. So this service kind of ignores everything else and say, hey, as long as you can create your Python function, but in the Python environment, you're good to go. It's already up and running, and you don't have to worry about all these machines and security and other different things. Obviously, you need to worry about.
Writing a linear regression code here, and we'll just.
Yeah, we can write. We'll see. I mean, in fact, here's an example code, right? So here's a function. So all you need to focus is on this function here, and it's basically saying, hey, if there's an input, it's ignoring the input completely and just returning saying, hey, this function got triggered. So that's why it's saying status code is 200, and you're saying hello from Lambda. Okay. It's just default answer it's saying. It's not processing anything which is coming to it. Because what comes to it also we need to hook it up, but we have not done that yet. So this is the function, and right now it's kind of useless because we can't talk to it yet. Okay, remember the HTTP protocol, the trigger gateway is not something that we haven't. So think of it as two blocks, the Lambda function block and the trigger gateway block, both together kind of are equivalent to the stuff that we did before. Okay, so
mostly the virtual machine that we rented and everything that we did was to run a PY file, which would run our regression.
Yeah.
This would essentially negate all those steps and jump on.
Yeah, that reminds me, let me cancel that stuff so that people don't oh, did I cancel it already? Yeah, I think I Control-C it already, so it should not work. Yeah, okay, it's not working. So let me come back here. Yeah, we are kind of skipping out. That's why I said two ends of the spectrum. We saw the one end of the laborious work, which you need to know a lot, right? You need to be kind of confident that it actually, you haven't missed anything. So that's why, most companies will probably go with this unless they think it's more cost efficient to, if they have full-time, DevOps engineers and people who can kind of stand up their own stuff, then it's pretty cost efficient to do your own stuff, right? You're not paying somebody else for the service. Here, they are pretty competitive, but at some point it becomes expensive to use other people's services. Okay. So we have this function. What we can do is add a trigger, and this is where the trigger / gateway that we saw in the slide. So we're gonna make a what's called a API gateway, and we can say, okay, let's create a new API. We're just calling it HTTP API. API is this application programming interface. HTTP is the protocol that we saw in the previous example, so we'll just follow the same. And here's where I think we're going to be lax here for just demo purposes for the minimum working example. But again, security is a big thing. So here we're going to say open, which is a bad idea. Okay. So the other option is, I guess, is a JavaScript web token or JSON web token? I don't remember, but there's ways to kind of authorize. So give somebody else, it's like very similar to the key pair thing. So somebody else, if they have the token, with that token, if they make a request, you see, oh, they have the right token, and therefore here's my response to you. Otherwise, you don't respond, right? So let's keep it open for now. Additional settings, I don't think we have to do anything. I don't, yeah, I think it's fine. Let's add this. So what changes in picture is that previously it was this, and then now there's an extra block here. This is exactly like that diagram in the slide, kind of related, similar. So this is basically what we have. And it already tells you this is the endpoint. So if I click there, it basically triggered that function, and we got that hello from Lambda, right? That's as fast as it can be, right? Faster than the previous stuff that we saw. But now, the only difference is like you can just edit the code here. You can edit it to actually respond. So that part, I think we do have an example, because that requires a little bit of like, how do we handle the context and event? There were two specific names that it's a little bit different from the Flask function, which was taking a request. In a request object, it was looking for arguments, whether feature vector was passed or not. Here it's a little bit different, but we can just look at it. Yeah, this is doing a lot more. It's actually preloading some extra data and then doing some stuff. But I don't know if it's very instructive to repeat this, but I will let you guys try this out. Basically, I'm trying to see, I'm just saying that you can actually change this function to actually now do the exact regression stuff that we did. It's just that we don't have a running example, ready example in our code folder for doing this. It's doing something else with a couple of extra files. I don't want to get into that detail. It's just noise. So this is how you run a function. Okay. So anybody can trigger it as long as I have that link. It's just open in some sense, but you can fix that. Okay. That's beyond the scope for now. Yeah. We don't. Yeah, we don't. No, but we wanted to do the regression. So this function is like that predict function inside the Flask py file, right? We just basically want this. Right, we just want this function essentially, but it's not exactly going to be like this, because Lambda will have a different. So here, for example, this is a object from which we are extracting the X value, whereas in Lambda it's going to be from context or one of these other variables. Okay, so that's a slight difference. That's all. We don't need Flask. We don't need Flask. Yeah, we don't need anything. We just need this function. If you just copy paste, it will not work, because as I said, the function signatures are different. That's all. Yeah. You don't. EC2 is literally rendering a machine and then saying, hey, I will do everything for. That's also to control costs. Okay. Yeah, Lambda has like a very generous. So you have to trigger it like thousands of times for it to actually cost you money, which seems like a lot, but in professional settings, it could be like it could be reached very quickly. Yeah, and it's not going to be as simple as this, right? We just did a very quick start. We did not even change the function signature, but generally a lot of MLOps and DevOps folks actually use Lambdas for many glue functions where they just need some extra functionality, but they don't want to spin up a computing environment to kind of do that. So they can quickly do a Lambda so that it can monitor something or trigger something or fetch some extra data and put it somewhere else. So it's just one of functions. As long as it's self-contained, you can do it. In fact, there are some choices. I think earlier you saw container image or some stuff like that. So there actually you can load up even scikit-learn. So if you see, it's just the function level, right? So what libraries are available to it? Is pandas available? Is scikit-learn available? Is PyTorch available? It's not. Okay, by default, it's not. So how do we get those things to be available? You have to kind of add some extra capability, like choose some extra choices and make some extra stuff available for this function to be able to use them. Okay. Right now, it only has standard library functions, as far as I know. Yeah. So you'll have to do extra work if you want to have some heavyweight extra packages that you need in your function call. Yeah.
So can we say that Lambda is just an aid? So let's say if you have to host like a full web page,
Yeah.
Can we do that on Lambda, or do we need? Or
Yeah, you can, right? So this, you can in the sense, so it has to return HTML. So where is that Lambda function? Sorry, this one. Okay, so here it's actually returning a JSON object. Okay, here if you return, so let's try it actually. Right, I don't know if this will work, but I don't know. Right, and then do h1. You know, it might work, but might not as well. So I'm just saying that if you want to return a web page, as long as some parts of it are the only things you want to modify, you can actually try it. And I don't know if it will work, but no. Internal server. Okay, it did not work. But all I'm saying is you can always serve a small web page if you want, but it needs to have access to that page so that you can serve it. Right. So that page either is saved in the, so remember, so I didn't go into these, but like there's a folder here, you can actually put extra files here that the function can access. So you can have a .html or whatever, index.html, and then you can return that index.html. Like you need to read it and then return it. But so also the reason why it failed is because, as I said previously, it was returning a JSON object. We need to be careful. Like right now, I'm just returning some text. That probably doesn't work. So we'll have to kind of look at the documentation. I think, yeah.
Does it have to be this?
No, it doesn't have to be JSON. It has to be JSON. Yeah. I mean, actually, okay. Let me recall. I mean, not say that definitively. It's just that the example code was JSON based, right? So I don't know if we have an example. Yeah, I'm still returning a JSON. So I don't know if you can serve a text directly. Yeah, it seems like it's more of a API server rather than a web server at the moment. I don't know if you can serve a. Yeah. Yeah, I mean, so inside the function, you can, even inside or even before that, you can preload things which will fetch data from a database, or if you have already a CSV file, you can put a CSV file in this folder, right? So actually there's an option right here, like upload from. You can just upload something like a zip file with the Lambda function and some supporting files, CSV files, if you want them to support your response. Yeah. But all I'm saying is we haven't done all that, and we should not get into that right now in real time. Yeah. So that's Lambda. Oh, it's already 8. So actually, should I do Google Cloud? It's very similar to Lambda. Okay, let me try doing it. It's not a.
How does Flask and all back of different Flask or
No, Flask is just a Python package, right? Lambda is a service which is proprietary to AWS. AWS doesn't let you. I mean, you can't do Lambda on something else. AWS Lambda on something else, right? It's a service versus self-host or some self-maintained thing. But both are doing exactly the same thing, right? They're serving. I mean, I didn't show the regression stuff in Lambda, but they both can do exactly the same stuff.
yeah, I think it's service to the local issue.
Yeah, in Lambda's case, you saw, right? We didn't have to care about anything else. We just asked, hey, give me Python 3.10. And then all we have to do is try work, do stuff inside this function, essentially. So in that sense, the scope is limited. In Flask, like Flask can actually serve web pages. You can actually say, if it's slash, then serve this function. If it's slash, regress, then there's some other function, slash classify, other function. All of them can be the 3 functions in the same file, and you can hit those endpoints easily. Here, you'll have to have 3 lambdas, each one taking care of different things. So there's those types of trade-offs, yeah. So actually, I do have, I think I have logged into Google Cloud. Yeah, so this is my Google, this is my, I guess, Google account, which just has access to Google Cloud. So generally what you do in Google Cloud first time you log in is create what is called a project. Okay, there's just a way Google organizes things. So I just call the project MLOps, but you can call what the project like test project or whatever. Okay, once you have a project, then you can do exactly what we did in AWS, right? So you can just go to, in this phase, it's called Cloud Function. Actually, even I think Cloud Compute would be the equivalent of EC2. You can do the same here. Okay, so let's go to Cloud Functions. And exactly the same, almost the same interface. You know, create a function, but there's going to be slight differences. Let's see those differences, perhaps. Okay, so it's saying, I don't know, environment. Let's just leave it as it is. Function name, function one. Okay. So it's saying HTTPS by default, but you can say unauthenticated invocations. That's you know, it's not a default because it's not secure. So it's saying this is the URL, and that's it. So you need to enable all this. I mean, if you haven't enabled something, then it'll say, I mean, by default, the first time you create an account, probably some things are not enabled. So you just enable them. I mean, I don't even know why those things need to be enabled, but there's some, you know, we can investigate, but I think it's not useful. So here's the, it's already showing the function in this case, JavaScript, but instead, let's just go to Python, right? It's a competing service. So yeah, so this is a Python environment. You choose the Python environment, and if you need extra packages, you just mention it in requirements.txt. It's very similar to how we do it in like you can have a requirements.txt, which is not there for many of the examples, but we should be adding requirements.txt, which says, oh, we need Flask, we need you know, pandas, we need NumPy. You know, that information should be there in an extra text file. So Google Cloud tells you, okay, this is how you would specify it, so that you don't have to upload them. In Lambda's case, you will have to upload the supporting files. Okay, those libraries, you will have to zip them up and upload it, which is a little bit of an extra step. I think it's mentioned in the notes, but we'll not go over them in this demo. Okay, so but if you see the main.py file is exactly the same. Hello HTTP, you know, a request, and it's just saying, okay, in the request, if there is JSON, then get the JSON things. Like if you do a post request, there'll be a JSON object. If you do, if there is args, which is generally a get request, and pick the arguments. And if there's name in the JSON thing, or if there is an argument that we gave, then hello, whatever. So let's just, actually it's already, oh, it's not deployed. So let's click deploy. So we can change this function signature. So it's actually nicely showing how to extract get parameters or even post parameters. Okay, so that's actually nice because you can actually, you don't need all these details, but it's the default here. So this is the URL, right? So if it starts, once it starts, then we can just click on it and give the name. And so we did not do anything, right? We did not care about any machine behind the scenes. Hey, just give me a function, and they generally these companies charge per invocation. So how many times you call the function is what determines how much it costs. Okay. Any questions about this part?
What is the security feature of Google?
Google also, we just chose unauthenticated, but by default it said HTTPS. HTTPS is not the issue. Yeah. So for cloud functions, you mean? What is the security aspect? Or
Yes.
I didn't see the authentication details. But you remember we just chose unauthenticated option. I don't know HTTPS, but then that's not really security related. I mean, it is security related, but it's not authentication related. There has to be some details. I don't know off the top of my head. Build finished. So it's taking some time. Behind the scenes, it's doing something, right? I mean, there are millions of users with, you know, both companies and individual users having tons of Lambda functions and cloud functions in these services. under these vendors. Yeah, that's it. So it's unauthenticated, so that's why it's, and then obviously because it also showed you how to right, so how to give command line arguments. This is exactly how we were doing for Flask, right? So now you have a ready-made code, you just have to change the function signature, and you have I mean, obviously, if you need to load the model from somewhere from disk, like a pickle file or a CSV file, if you can add it to that, if you can, I don't know, in cloud functions, let me go back here. Edit. Yeah. So, sorry, code. So in Lambda, you can add extra files here, like a CSV file or pickle file or something. I don't 100% recollect whether you can add files here, but if you can, then that's how you read it. Okay. But I'll not try it in real time. You just have to look at the documentation. Okay. Okay. So I had plans to show GitHub and Git, but I think I will pause unless you want to. I'll pause for 10 minutes. But the plan, like last time, was you guys try out something, renting a EC2 machine or a Google Cloud Compute machine, or try out these Lambda functions and try to get your regression prediction into these. Would be the exercise to do during the next hour. But if people want, we can go to Git. But let's take a break for 10 minutes for doing that. Yeah. Okay, so I mean, the plan is for you guys to try out what we saw. Okay, there's not going to be more lecture component, but I just wanted to show you, just at least for cloud functions, how simple it was to go from. I just commented out the previous stuff that we saw right before the break, right? Those lines which said "Hello World" or whatever, and then I just copied the part which is there in a Flask regression example. Okay, and obviously there's no model function, so I just added the model coefficients right here, but you could change it to, include other functions or whatever, right? This is exactly our predict function in the Flask _regression, simple _regression _service by file that we have, right? Exactly the same. It's just saying JSONify input and just tell me what the transformation of the input is, and I'll say, okay, there's no input that was passed, and that's it. So this is exactly the same results we've been seeing from last week as well as earlier today, right? So at least on the cloud function side, it's exactly, as long as you have a Flask app, just copy the function that you want, which gets triggered verbatim into this, because it turns out, at least the generation 2 thing that they actually expect a Flask type of request object anyway. So that means that if there are get arguments, then they're going to be in the request.args dictionary. Okay, so this is just a minor comment that you can just copy paste whatever function whatever you have. So the way you should work is create a Flask app, run it locally, ensure that the Flask thing is working, and look at the dependencies. As long as you can somehow get the dependencies here, you just have to copy that function in the Flask app that you want to get triggered. Okay, and then yeah. Yeah, I just needed it because I wanted to use JSONify here. I don't know why natively if it's already loading Flask or not. So I needed Flask because I didn't need Flask app, right? I just needed a function called JSONify.
That was in Flask package.
Yeah, that's why.
It's not doing anything.
No, it's not doing anything. Yeah, it's not doing what we were doing with Flask on web server part of it. Yeah. Maybe instead of JSONify, there is also JSON-S to make it into string or something. I think JSON.dump string or something. Like there's some other package that you can try. Yeah. Okay, that's where this kind of pauses. So the idea is you guys try and I will help you. And so if anybody has any hiccups, call me and I will be at your desk.